we're just going to get into this today. So basically what I have on the right side of the paper is just like an explanation. So if you wanted to go back and read it of what we're going to do to factor this. But it's very similar to the process we did on Friday. The main difference is the a value will not be 1. So I'm still going to multiply a times c. It's just in our previous lesson when we were doing that, the a value was always 1. So just going to be a different number today. So a here would be 2, and c here would be -4. You want to take those two numbers, multiply them together, so that would give you -8. And you want to always add up to the number in the middle, which is your linear terms coefficient, the b value, which should just be -7. Okay, just like the last time we were working on this, there's only two numbers that'll fit both of those requirements. So just hold off on that for 1 second. I'm going to start out, and I need 2 sets of parentheses to write my factors. What you want to do that's just slightly different than what we did for an a value of 1. Whatever that first term is, and it's different in each of these questions I've got on here, whatever that first term is, you're going to drop the squared and write that at the beginning of each of the factors. So for this question, that first term is 2x squared, so I'm going to put a 2x at the beginning of each of the factors. Now you can probably go, oh, Miss Grody, hello. If I foiled that back out, I could tell you right now 2x times 2x would give you 4x squared, and you'd be correct. But that's what this method just has a little trick to it. Okay, so first term, drop the squared, put that at the beginning of each of the factors. And I'm going to fill those in with the two numbers that fit these requirements. So can anybody think of two numbers when you multiply them, you get -8, you add them, you get -7? Good, okay. One has to be -8, the other has to be 1. -8 times 1 is -8. -8 plus 1 is -7. Doesn't matter which one. So just make one of them a -8 and fill the other one in with a +1. It doesn't matter which one comes first or which one comes second. Okay, again, this is not going to be the answer because if I foiled that back out, that is not going to be the factored form of what you have written above here. Okay, here's the little trick to this method. What you're going to look in your set of parentheses. If those two terms have something in common, that's not the real factor. And sometimes neither one is going to be correct, and sometimes one is correct and one's not. We're going to go through that, how to decide today. So, do 2x and 8 have anything in common? What do they have in common? 2. It'll just be a number. Okay, now I know this is weird, but this is not factoring something out. You don't pull anything out in front of the problem or anything like that. It just means that 2x minus 8 is not the real factor. Okay, to get the real factor, it is literally like almost like reducing a fraction. I'm just going to divide both of those terms by whatever they have in common to get the actual answer. So the real factor there should have been x minus 4. Okay, now for the other factor, do 2x and 1 have anything in common? Just 1. Okay, so this is the real factor. So I'm just going to copy that right down here. This should then be the factored form. And it's a little bit faster, in my opinion, to do this Berry method than sitting there and trying to do trial and error and all kinds of stuff to get these combinations to work out. I do recommend, especially on these questions, just kind of spot check a little bit. You could completely foil this out, but I at least check the first term in each. If I foiled this, right, x times 2x would give me back that first term, which is the 2x squared, and I check the constant. So if I take these two numbers, the -4 and 1, multiply those should give me the constant. -4 times 1 is -4. So I should be okay. If you want, I'll do it on just this question. If you were to completely foil this out, right, I'd get 2x squared plus x minus 8x minus 4, which would give me back the 2x squared minus 7x minus 4. But at least try, when you do these, at least check the first term and the last term, and you should be okay. Does anybody have a question? Okay, I'm going to scooch this up. Like I said, all that's over here to the right is just an explanation of what I just did. All right, so let me try this again. So this is 5x squared minus 13x minus 6, and I should have said this for the last problem. Before you start, you should really always check to see if all the terms have something in common that you could divide out in front. So like 5, 13, negative 6, they don't have anything in common. So this is, I'm just going to go from here, but try to check that for the question. See if you have a greatest common factor before you start. You do not for this question. To write the factors here, I'm just going to take that first term, which is 5x squared, just drop the squared, and write that at the beginning of each of the factors. Okay, to fill those in, you're going to multiply a times c. For this question, it would be 5 times negative 6, and I want to add up to the b value. For this question, that's negative 13. And so if I actually multiply those, I have to multiply to get negative 30, add to get negative 13. This one's kind of tricky, so think about it before you answer. What two numbers when I multiply them would give me negative 30, add them, get negative 13?
Negative 15 and 2.
Thank you. Okay, a lot of time people say 10 and 3, but that will not work here. It has to be negative 15 and positive 2. That'll multiply to give you negative 30, negative 15 plus 2 is the negative 13. Okay, so you're just going to fill in your factors. So just make one of them a plus 2 and make the other one a minus 15. Now again, if you're looking at that, you're like, 5x times 5x gives you 25x squared. So either one or both of these is not the real factor. Okay, for the first one I wrote down, do 5x and 2 have anything in common? No, so we're good. So this is the real factor. Now, do 5x and 15 have anything in common? 5. Okay, so this is not the real factor. These are both divisible by 3. So to get the real factor, it's literally like reducing a fraction. You're just going to divide both of those terms by 3. You do not bring it out in front or anything like that. It's just a little trick to this method. What would the real factor be for the second set of parentheses that I wrote right there? I don't know why I wrote a 3 when we said 5. Okay, sorry. They're both divisible by 5. My fault. What would the factor be? X minus 3. And this would be your answer. And again, I just kind of spot check. Like 5x times x, right? That gives you back the 5x squared. 2 times negative 3, that should give you the constant term, which is negative 6. If you want to completely FOIL it out, you know, you're welcome to do that to check. But if you just at least check those two, you should be okay. Okay, and I have one more, and then we'll do like one that has a little bit of extra work at the bottom. So this is 9x squared plus 12x plus 4. 9, 12, 4. You don't have anything in common, so no greatest common factor there. So what I want to do is multiply a times c. For this question, that's going to be 9 times 4. And I want to add to the b value, which is just going to be the 12. So if I actually multiply 9 and 4, what I need are two numbers that multiply to give me 36. The same two numbers add to give me 12. So I'm going to start out each of my factors. The first term there's 9x squared. So I'm just going to start each of the factors with 9x, drop the squared. What two numbers will multiply, give you 36, add, give you 12? Yes, okay. 6 times 6 is 36. 6 plus 6 is 12. So actually both of these factors are going to be identical. Now, if we multiplied this, right, 9x and 9x would give us 81x squared. So not right. What do 9 and 6 have in common? 3. Okay, so actually neither one of these is the real factor. Both of them I could reduce by 3. So to get the real factor, again, I don't put a 3 out in front, nothing like that. To get the real factor, just divide both of those terms by whatever they have in common. The real factor here, this would become 3x plus 2 times 3x plus 2. If you want to do a quick spot check, 3x times 3x give you back the 9x squared. 2 times 2, the two numbers multiplied should give you the constant, which is 4. I can, because these are identical, write my answer as 3x plus 2 squared, since there's 2 of them. Anybody having a question? Okay. And I have one more at the bottom here. And then there's no back. There's always a back, but there's no back today. Okay, now, 8, 8, and 70 are all divisible by what? 2, just 2. No big deal, just 2. All right, so my greatest common factor here, and if there is in any of these problems, before you try to apply any of the rules I've told you about factoring stuff, if there is a greatest common factor, you need to pull that out in front first. Now, if I actually had an equation here, we don't have an equation, there's no equal sign, I could just get rid of the 2 if I had an equation. I can't do that here because I'm factoring this expression. So what I would need to do this correctly is put a 2 out in front. All right, now I do need that 2 out in front. Leave me with 4x squared minus 4x minus 35. So otherwise I'm not given an equivalent expression. So I do need the 2 out in front here. From that point, I would just ignore that for a second, and I'm just going to focus on the quadratic that I have in the parentheses there. So we do need a 2 out in front. And I'm just going to apply that Berry method. So just focusing on the quadratic, that first term inside there is 4x squared. Just going to drop the squared, and I'm going to write 4x and 4x to start each of the factors. For this question, just focus on what's in the parentheses there. A times C would be 4 times negative 35 there. That's going to give you negative 120. And I always want to add to the B value, which is just the number in front of your plain X. And so that's just negative 4. Oh man. Can we think of 2 numbers we multiply? No, I just did that wrong. It's 140. It's 140. Don't judge. It's unkind. No, I'm just kidding. 140. Okay. Can we think of 2 numbers if we multiply them? We get negative 140. And if we added them, we get negative
14 and 10.
There we go, okay. Negative 14 and 10. I will not give you any factoring problem that you can't factor, so just keep that in mind. Negative 14 times 10 would multiply to give you negative 140. Negative 14 plus 10 would add up to negative 4. There's only 2 numbers that'll fit both requirements. So just to fill in the factors, make one of them a negative 14, make the other one a plus 10. And then this is actually a situation where neither one of these is the correct factor. So what do 4x and 14 have in common? 2. So I'm going to keep that 2 out in front to keep my factored form. And this would become 2x minus 7. I'm not pulling that out in front or anything like that. It just disappears. What do 4x and 10 have in common? Also a 2. Now, in this example, it's the same number. It does not have to be the same number. You could have 2 different numbers, like maybe they're both divisible by 3 or 5 or whatever. So it does not have to be the same number. The real factor here would be 2x plus 5. And then if you want to just spot check real quick, like with what I have here, 4x squared minus 4x minus 35, 2x times 2x, 4x squared, negative 7 times 5 would give you back the negative 35. The 2 out in front is trying to match it back up with the original problem we had, and we do need that. Does anybody have a question?